Hi, and welcome to 4.2 Newton's second law. In this video, I'm going to show you how to do numbers 1, 2, and 3. Then I'll show you the solution for 4, 5, and 6, but I'm not going to narrate it, and 7. Then I'll show you how to do numbers 8, 9, and 10. It's very important, if you did not try these problems on your own first, please try them and then watch me work them out. It's a lot more important for you to work through the problems on your own and see if you can figure it out before you watch this video. Alright, so Newton's second law has to do with this formula here. The acceleration is directly proportional to the force acting on an object and inversely proportional to the mass. Really, it's the net force. But since all of these problems are just dealing with one force acting on the object, we won't really talk about the net idea yet. That's in the next homework. We can rearrange this formula. We could cross multiply, and it gives you force is equal to ma. So we're going to use these two types of formulas to do these problems. So let's do the guess method. Given unknown, equation, substitute, and solve. It says how much force, they're looking for the force, is required to accelerate a 2 kilogram mass at 3 meters per second squared. Okay, so there's our givens, our unknown, where you got to pick an equation to use. Since we're solving for the force, I'm going to use F equals ma, because it's already solved for the force variable. So F is equal to 2 kilograms times 3 meters per second squared. Force is equal to 6 newtons. Number 2. A box is pushed with a force of 100 newtons. Now they tell you what the force is. And it's causing it to be accelerated at a rate of 10 meters per second squared. What is the mass of the box? Believe it or not, we could calculate what the mass is, because the more massive it is, the less it would accelerate. If it's less massive, it would accelerate more given this 100 Newton force. So we could use Newton's second law to calculate the mass. Again, we'll use F is equal to ma. 100 newtons is equal to the mass times 10. And the mass is equal to 10 kilograms. Very good. Number 3. It says, what is the acceleration? So number 1, they're looking for the acceleration. Number 2, they're looking for the mass. They're looking for the force here, then the mass. Now they're looking for the acceleration of a 10 kilogram box, or a mass being pushed by a 5 Newton force. So instead of using F equals ma, since we're looking for the acceleration, why not use good old A is equal to F over m? So the acceleration is equal to 5 divided by 10, which is 1/2, 0.5 meters per second squared. Okay, so if you didn't do this yet, try them out. I'm going to pause the video now and work these other guys out. Then I'll show you the solution, and then we'll do 8, 9, and 10 together. All right, let's see. And here we go. So number 4, 56 newtons. Number 5, 60 newtons. Number 6, 18 kilograms. And number 7, 0.4 meters per second squared. Now we get to the asterisked ones. Oh man, 10 is a double asterisk. Watch out. So 8 says a 50 kilogram box. The mass of this box is 50 kilograms. Is being pulled by a rope across a horizontal frictionless surface with the force of 30 newtons. So the force is 30 newtons. Next sentence is a doozy. It says the rope is making a 25-degree angle with the horizontal. What the heck? Alright, so we have this box, and we're pulling it with the rope, but not just straight across. We're pulling it at this weird angle. Alright, so this is 25 degrees, and the force is acting along the rope. Oops, not 20, but 30 newtons. Alright, it says, what is the acceleration of the box? Well, it's not accelerating in the direction of this force. It doesn't say you're lifting the box up. It says you're sliding it across the horizontal surface. So the acceleration is going across this way. So Newton's second law says that the force and the acceleration have to be in the same direction. this force is not in the same direction as the acceleration, we need to find the component of the force that is acting in the same direction as the acceleration, the part of this force. All right, so this is the x direction, so we're looking for F sub x. We could draw ourselves a nice triangle here. This is the force, the component of the force that's going upwards. Makes a nice 90-degree angle right there. And as you can see, if we're looking for F of x, because that's the one that's acting in the same direction as the acceleration, this would be the adjacent, that's adjacent to this angle, and they give you the hypotenuse. So if we have adjacent and hypotenuse, we're going to have to use cosine. Now you could use the shortcut. You're going to do 30 times cosine 25. If you forget that, just remember cosine of 25 is equal to the adjacent over the hypotenuse. Now you cross multiply and you get Fx is equal to 30 times cosine 25 degrees. You plug this in your calculator. Make sure that your calculator is in degree mode, and you should get 27.2 newtons. So the x component of the force is 27.2 newtons. Sure, you're pulling up at 30, but only 27.2 is going exactly horizontal. And that's the force, that's the part of the force that's causing this acceleration. Okay, so now that we know that force, we're ready to do Newton's second law, which is A is equal to F over M. The acceleration is what we're looking for. Now it's very important, we're using the x component because that's the one that's going in the same direction as the acceleration. So we have to plug in 27.2. We did all that work. Why plug in 30 now, right? So we found the x component. And it's a 50 kilogram box. So the acceleration is about half a meter per second squared, 0.5 meters per second squared. And there's your answer. That's it. All right. Number 9, kind of similar. It says a box is being pulled by a rope with a force of 57 newtons. Okay. The rope is making a 45-degree angle with the horizontal. The box is accelerating at 10 meters per second squared. Now they tell you the acceleration, and they're asking for the mass of the box. Kind of strange. Remember, it's at this 45-degree angle. Best thing to do, draw yourself a nice picture. Doesn't have to be to scale or anything. You don't need to break out your protractor. 45 degrees. This force being pulled along the rope is 57 newtons. The acceleration is in this direction, 10 meters per second squared. So we need to know, again, the x component of this force. You could draw yourself a nice triangle, and you could do the whole trig function, but we've done this a bunch of times. So we know Fx is equal to the hypotenuse, 57, times the cosine, because this is adjacent to this angle, of 45 degrees. So Fx is actually equal to 40.3. 40.3 newtons. Okay, this is the part of the force, the component of the force that's causing the acceleration. Now we're ready to do our calculation. So let's look for the we're looking for the mass, not the acceleration, right? We know this. So we could just do F is equal to ma. So 57 is equal to the mass times, I almost did it. I did it. I plugged in the wrong force. It's the x component, ma. This is the x component. So this is 40.3 newtons is equal to the mass times 10. Hopefully you caught that. You're like, what the heck? Why is he doing that? All right, so the mass is equal to a little over 4 kilograms, 4.03 kilograms. All right, that's the mass of the block. Moving on. This one's tricky. Double star for a reason. You have to do it backwards. You're doing it backwards. I'll show you what that means. So the mass of the box is 20 kilograms. You pull a 20 kilogram box with a rope so that it is accelerating at a rate of 1.5 meters per second squared along a horizontal frictionless surface. the rope is making a 60-degree angle with the horizontal. What force are you exerting on the rope? That's this guy. We want to know what the force is on the rope. You should draw yourself a picture here. Because again, we have this angle. Boom. 60 degrees. We're looking for the force along the rope. If we do Newton's second law, we're actually finding this force. So let's do that. That's a good place to start at least. So F is equal to ma. The force is equal to the mass times the acceleration. So the force is equal to 30 newtons. But that's not the force along the rope. That's this component of the force that's acting in the same direction as the acceleration. This is causing this. But they want to know what this is. Alright, so how are we going to do that? It's just trig. Here's your triangle. This is the adjacent. This is the hypotenuse. So cosine of 60 is equal to your adjacent, which is 30 newtons, divided by the hypotenuse. And when you cross multiply, you get 30 is equal to F cosine 60 degrees. And when you divide by cosine 60, you get 60 newtons. You get 60 newtons. That's this force. 60 newtons. That's the answer. Not 30. They're saying, what force are you exerting on the rope? The hypotenuse. Very tricky. Alright, hopefully this helped. Have a good day. Have a good night. And I'll see you in class.